Students, in this video, we will study about pair of straight lines and its properties. Pair of straight lines. Pair of straight line means if one line is a1x plus b1y plus c1 equals to 0 and other line is a2x plus b2y plus c2 equals to 0. All terms are in one side. If any term is on that side, then transfer it to LHS. And all terms must be in left hand side. And in right hand side, there must be 0. And now multiplying them. a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. This is pair of straight line. If we multiply these two equations, we get a1 a2 x square plus a1 b2 plus a2 b1 xy plus b1 y square plus a1 c2x a1 c2 plus a2 c1 plus a2 c1x plus b1 c2 plus b2 c1 y plus c1 c2 equals to 0. One, two, three, four, five, six, seven, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 3 terms in this bracket, 3 terms in this bracket. In multiplication, there must be 9 terms. These are 9 terms. This is multiplication of these two brackets. So this equation, see it carefully. This equation is of second degree. So this is called general equation of second degree. X square second degree term, xy second degree term, y square second degree term, x and y first degree term, and this is constant free from any variable. So this type of equation represents a pair of straight lines. And now homogeneous equation of second degree. Homogeneous means if all terms are of same degree in any equation, then equation is called homogeneous, like ax square plus 2hxy plus by square is equal to 0. This term consists 3 terms. This equation consists 3 terms. First term, second term and third term. In first term, power of x is 2. In second term, power of x and y together is 2 and power of y is 2. So this is called homogeneous equation. And since power of variable in each term is same as 2, so this is called homogeneous equation of second degree. And this is the form of general equation of second degree. The difference is two lines represented by this equation, which are this and this, will never pass through origin. This is coordinate system. Two lines, these two lines may be like this and this or this or this, but they will not pass through origin. But the equation of lines represented by this homogeneous equation of second degree will always pass through origin. And if line pass through origin, actually equation of line by is equal to mx plus c. And if we talk about this line AB, which is making intercept origin. So this is by intercept, which is denoted by C. And if we draw a parallel line to AB, below AB, then value of C will reduce, and more value of C again reduce, and when this line will pass through origin, then C will vanish. This will be 0, and line will be of the form y is equal to mx. So this equation, homogeneous equation of second degree, will represent two straight lines always, and they will pass through origin. So lines are y is equal to m1x and y is equal to m2x. These two lines both are passing through origin. So C is absent in this line and this line both, and these lines are represented by this line. M1, M2 are their slopes. So sum of slopes M1, M2, sum of slopes, if we have pair of straight line ax square plus 2hxy plus by square equals to 0, the slope of lines represented by this pair be minus 2h upon b, and product of slope m1 m2 equals to a upon b. Suppose we have x square minus 3xy plus 2y square equals to 0, a pair of straight line, homogeneous equation of second degree, and this will represent two lines, and we have to find the sum of slopes represented by this line. So m1 plus m2 sum of slopes be minus 2h upon b, minus 2h. H is here. Compare this equation with this equation. 2h is equal to minus 3, so h equals to minus 3 upon 2. 2h is equal to minus 3, coefficient of xy is 2h, coefficient of xy is minus 3, so 2h equals to minus 3, h is equal to minus 3 upon 2. And value of b is by coefficient of y square, which is here 2. So this 2 and this 2 will cancel, minus minus plus 3 upon 2 is sum of slopes. Product of slopes m1 m2 is a upon b, and a upon b are a is coefficient of x square, coefficient of x square is here 1, b is coefficient of y square, and coefficient of y square in this equation is 2, so 1 upon 2 is product of slopes. So slopes may be obtained by using these two formulas. Second thing, so one thing, homogeneous equation of second degree always represents a pair of straight lines which passes through always origin. And equations we like y equals to m1x and y equals to m2x because they are passing through origin. So value c, the term c will absent always here. And now nature of straight lines. Nature of straight lines represented by ax square plus 2hxy plus by square equals to 0. Nature of straight lines. Number 1. If h square is greater than ab. Second degree equation, homogeneous equation of second degree is this. Find value of h, a and b. If h square is greater than ab, then lines be real and distinct. If h square equals to ab, then lines be real and coincident. Third, if h square is less than ab, then lines be imaginary. lines be imaginary. Nature of straight lines. Now, angle between two lines represented by this pair of straight line. Angle between two lines represented by ax square plus 2hxy plus by square equals to 0. Theta is equal to tan inverse 2 root h square minus ab upon a plus b. This formula gives the angle between two lines represented by the homogeneous equation of second degree. If we have two separate equations like y is equal to m1x and y equals to m2x, then formula will be tan inverse m1 minus m2 upon 1 plus m1 m2. If two separate lines are known, then we may use this formula. M1 M2 are slopes of two lines. And if we have no two separate lines like this pair of straight line, then find A, B and H from this and substitute values of A, B and H in this equation, in this formula to find angle between lines. And now if a plus b equals to 0, a plus b equals to 0 means sum of coefficients of x square and y square is equal to 0, or from this formula m1 m2 is equal to minus 1, then theta equals to 90 degree. Or we can say theta is 90 degree means two lines are mutually perpendicular, then a plus b equals to 0 or m1 m2 equals to minus 1. Second thing, if h square equals to ab or m1 equals to m2, then two lines are parallel or coincident, the theta equals to 0 and lines will coincide. Lines will coincide. In this case means homogeneous equation of second degree is representing two lines. They will never parallel. They will always coincide because both lines will pass through origin. If two lines are passing through origin and theta is 0, so they will always coincide, they will not parallel. And condition of parallelism and condition of coincidence be same as theta equals to 0, for theta equals to 0, m1 equals to m1 and h square equals to ab. H square equals to ab if pair of lines is known. m1 equals to m2 when two separate lines are known. So this is the topic of pair of straight lines completed here.